Okay, so yesterday we had a look at the start of reducing balance depreciation. So that's when your the item is depreciating by the same percentage every year. It's actually geometric decay, which means you are timesing it by a number less than 1. So what we saw when we did them, so that big R value that we find out, it was less than 1. So you saw you were timesing it, say, by 0.93 or whatever, and that's what we saw. So here we're going to, instead of doing it recursively, which means like you just keep getting the next one using the one before, we're going to go and use the nth term formula. That means we can get any time value. So say if we wanted to know what the cost of the machine or something after 30 years, we can go straight to 30. Okay, so if you look at the nth term formula, you can see it has that value in there. So we know how we find the R. There's the formula here. And just remember, it says annual interest rate. They may write that as per annum rate. Okay, so just be aware that means the same thing. And you can see they're using the VO. Now down here it states that the VO is the amount borrowed, but you might want to write it's, say, the initial price. Sorry, I can't spell. So the initial price or starting price, or starting price, whatever or starting value, okay? So you might need to refer to that as that. Okay, and N is just the number of times. So if it was 5 years, N would be 5. All right, so let's have a look at some questions. So it says here, and you want to get into the practice of doing things like what I'm doing here when I do it. So it says a computer system costs $9,500. So because that's at the start putting things like, all right, that's VO, okay? And it says, and it costs that to buy, and it decreases in value with reducing balance depreciation. So you want to get in the habit of highlighting that, because as soon as that's telling you which one you're using, because unless they tell you, you don't know. So now that we know, when you're on your formula summary sheet, you'll be going to the reducing balance depreciation section. And remember, this is the recurrence formula like box, and then this one is the nth term box. So this is what we'll use for the nth term formula box. That's where we go. Okay, so anyway, it's reducing balance depreciation of 20% per year. So what they gave me there was the R. So per year is the same as per annum. And they've actually given me the recurrence relation for this situation that shows year to year. So this bit here is the recurrence relation, okay? And we can see that because that's got the VO and then it's got that N+1 rule. So that's the recurrence relation written there. So this number here, if you look at this number here in that recurrence formula, what that is that big R. They've already calculated it and worked it out to be 0.8. So in the first question, when it says write down the rule for the value of the computer after n years, that means you want to find the nth term. So here I've gone to the formula sheet and I've grabbed that nth term formula, and I can see the things I have to change are like the R. Now because I can see what the R is in the recurrence relation, I'm going to straight away put that number there. Now it's to the power of n, okay, and that's good, and then times VO. Now I'm not going to write VO, I'm going to write exactly what VO is, which is 9,500. So this, now I've created the nth term formula, yeah? So I can get the value at any year from now on. So it says use this rule to find the value of the computer system after 8 years. So that would mean n equals 8. Okay, so means I'm trying to find V8. So every time I see an n, I'll put an 8. So it's to the power of 8. So on your calculators, you're going to have to pop it up as the power. And if you remember, you use that little arrow button. And when we do that, all you have to do is type this bit into the calculator and you'll get the answer of 1,593. Now it said to the nearest cent, so how many decimal places does that mean? 2, good. So it's depreciated, which means it should have gone down in value, so it definitely has. Okay, and then it says calculate the depreciation. So depreciation means just how much has it gone down by, not what the value is now, how much has it gone down by. So I've put a little note there. Depreciation would be the original price, which is 9,500, minus the current value, because they said at 8 years how much has it dropped. So we found that in the answer before, and we pop that in and we get it's dropped by that amount. Okay, so 7,906. Now they try to use real data in your questions and in your exams next year, and they are trying to be realistic. So if you think about a computer over 8 years, it will drop that much. If you think about if you had an 8-year-old iPhone, that is very much, it's not worth much, is it? Compared to your brand new one now. So things like technology do depreciate very quickly, and so you can have a look. If you found that after 8 years in your scenario it had only gone down by $20 or something, you've probably done something wrong. So these are the things that help you trigger that you might have made a mistake somewhere. So you should always logically think, what should my answer, or is that make sense, is that one okay? All right, the next one, an industrial weaving company purchased a new loom at the cost of $56,000. So obviously you know that's the beginning thing. It doesn't matter if you don't know what the actual things are, you still probably can work around it. But a loom is like a industrial sewing machine, and obviously this is a weaving company, like they make some type of material thing. So that's what a loom is. Now it estimated the value of 15,000 after 10 years. So what they told me there, when they tell you a value after so many years, they're actually telling me V10. So I know V10 equals 15,000. And if the value of the machine depreciates using the reducing balance method, so you know you're using the reducing balance method, so you know to go to that part, that section in your formulas. Now, the question is, what is the annual rate of depreciation? So often you should write, well, that means that little r is my question. So somehow you should be able to fill in a formula with all the other details except for the r, and you'll be able to solve for it. So what I've done, because they gave me V10, I'm going to use, this is the nth term formula. I'm going to use that. And what I'm going to do is, if I wrote V10 would equal 1, now, R over 100 to the power of n times VO. Okay, so what we're going to do, you can see you can pop all this. Now, if it's V10, it would be the power of 10. Okay, now we can pop in all those, some other pieces of information. We know the actual value at 10 years is 15,000. And we know the rate is what we want to find out, so that one will be left as R. We've got the 10, and then we know VO is 56,000. So you can see the only thing that's not known numerically there is that R, and that's what we wanted to find out. So we go solve, comma, R. Now I've done it down here. This is what you should see on your calculator when you do it. Now you get these two answers. You're not going to get a percentage rate of 187, aren't you? Because the percentage 100 would be the max, okay? So when we see the percentage rate we just take, when you get the 2, just take the smaller one. Now, the question asked us to do 1 decimal place. So when we write our answer, we'll just write rate equals 12.3%. Pop a box around it so people know what the answer is. Okay, so this one is from an exam. So I'm just going to show you how we go about doing it the same way. So the purchase price of a car was $26,000. So in the exam, so you're going to start getting to the habit, know that's VO. Now, using reducing balance method. So I told you they will, the car depreciates, okay? So you know you're doing reducing balance depreciation. So you go to your formula sheet and you find the reducing balance depreciation section, and you know you've got to be using that. Now, it says it depreciates at 8% per year. So you know that's little r. And they want you to write a recurrence relation for this scenario. Instead of using V, they're saying C, okay? And it doesn't matter, and we go, okay, we'll use that. So we go over here. This is where we've got the recurrence formula. And you can see this bit is what we need to write out. So when we write it out, we have to replace that R with what actually it is. So the R is calculated, I'm just using the formula there, it's 1 over PPY, that's how many times a year. So if we look in this example, they're just saying every year, so we're going to say 8 over 1 over 100, and you'll end up with 0.92. So you know that the formula, if I follow this pattern, the formula should have the VO, which is 26,000, and then you should have the Vn plus 1 would equal 0.92 Vn. So if you look, which answer is that one? A. Now, other ways you could have got around this without even actually calculating that part. Because if you have a look, I could have eliminated a fair few of them. This one, is that depreciating? That's growth. So we could get rid of that answer. This one also is growth. Now this one, this next one here, this is like a flat rate depreciation, yeah? So you could say this is flat rate depreciation because it's not being times by something less, it's just taking away. So that one was out. And then the last one, our formula doesn't have that extra bit in it, does it? So we could have got rid of that. So you can see that might have been a quicker way you could have answered, and that allows you a bit more time in the exam.